The first type of problem we're going to talk about are wind and current problems. You see this in example number 27 on page 285. In this problem, it talks about taking an airplane trip from Philadelphia to Chicago and vice versa. And it talks about traveling with the wind versus against the wind. And how one trip with the wind only takes an hour and a half, while against the wind, it takes 2 hours. Now, if we think about this, if we are traveling in a plane going in one direction, and we have an opposing force, the wind, coming in another direction, what happens is it slows down. Going against the wind or against the current, if you're in water, makes our pace go slower. So if we represent the plane speed with x, and the wind speed with y, and we're going slower, we take the wind speed and subtract it from the airplane speed. The opposite happens if we're going with the wind. If you think about it, if you're traveling in one direction and you have a force coming behind you, pushing you, that's going to make you go faster. So again, the black line represents the airplane, the red represents the wind. So what we're going to do with that is we add those together. Because again, we add the rates together to make us go faster. If we go back to problem number 27 on page 285, we talked about a flight going from Philadelphia to Chicago with a distance of 780 miles. On one trip, with the wind, the flight took 2 hours. On the return trip, it took them an hour and a half. If the wind speed is the same on each trip, find the speed of the wind and find the speed of the plane in still air. As you can see, I've set up a rate times time equals distance chart. And the reason why is because in the problem it talked about a distance being 780, it talked about time it took, and it talked about the speed. So we know, or should know, that it's a rate times time equals distance problem, and we set up a chart. It also is comparing two things. It talks about the flight there, which is with the wind, which takes an hour and a half, and against the wind, which took 2 hours. Now, hopefully this should make sense. If we're going against the wind, it's slowing us down, and that's going to take longer than the hour and a half when it was with the wind. Going back to the first slide we talked about, if I'm going with the wind, I'm adding the wind speed to the airplane speed so that I can go faster. Again, we're adding the rates because I'm moving faster. It helps me to increase my speed. If I'm going against the wind, I subtract the wind because it's coming against me, slowing me down. Now, if you think about how we work with this, or how we're supposed to set up these problems, I should have probably labeled what my x and y is, like I did on the first page. X is the airplane speed, and y is my wind speed. Now, because this is a rate times time problem, what I'm going to do is I'm going to take the rate, times it by the time, and that will equal the distance. I do this for both of those. On this slide, you can see what those two equations look like. What we did is we took the rate, multiplied it by the time, and that equals the distance. The same thing occurred in the second equation. Now, when I go to solve this, I can do this in one of two ways. I could distribute the 1.5 and then solve from there. And I could distribute the 2 and again solve from there. But because this is multiplication in here, what I can do is I can divide both sides by 1.5. And I can divide this one by 2. And what happens is, because those are quantities, that will cancel out. That gives us nice equations to work with. And from here, we can use substitution or elimination. Now, what I'm going to do is I'm going to use elimination and add these together. My y's will cancel out, and I get 2x equals 9, 10. And if I divide by 2, I get x equals 455. And because I represent an x with my airplane speed, 450 miles per hour is my airplane speed. What you then do is go back to one of your original back to one of the equations, and you plug in 455 for x and solve for y, and y equals 65 miles per hour, and again, this is the wind speed.